So, welcome everyone. This is the second real session, and today we're going to do something new. Last time we did some bug hunting for the engine stuff, and if you checked the short video yesterday, you might have seen me aborting the whole video because this was a really shitty process and it took me a few hours to debug it to a point where I understood the problem. If you're interested, when I import keys into the engine, they are set by default to not allow any kind of decryption work. So instead of doing some complicated API engine calls or whatever, I figured out they stored these attributes just in an SQLite database. Mind, this is an emulator. And so I just really dirtily execute an SQLite command and reset these attributes before executing the engine after the keys were imported. So yeah, that's the idea. That's what I did to fix this bug, because these are just unit tests, so we don't really care. Right, let's take a look at what we can do today. So, head over to our issues page, and I cleaned up a little bit yesterday, so we have some issues we can address, and they are a bit more sorted. So these are the ones that belong to the milestone we are currently working on. So let's take a look what we could do. So this one is basically if I run make on my project, or cmake and make, let's say make clean, make, then we see that it is linking all the tests. And because we did those engine tests and a lot of other stuff, we actually don't want to build the tests all the time if we only need the library. So the normal user not wanting to run tests, well, they don't need to build the tests actually. So my idea is to split that out. This could be nice work, but I guess this is mostly reading CMake documentation, not so much implementation. This is engine related, of course, because if you look at the engine tests, you will see that I did something really, really nasty. Where do we have it? Right. I call the system function on the soft HSM as well as the SQLite command. And this is really, really dirty. And the SQLite thing should be fairly easy. I just add the SQLite dependency, link against it, and take a look at how to execute an SQLite command in C, because I haven't done that before. But the soft HSM part is actually harder. The library or the functions that contain the code get linked into a binary but not into the library, and the header files are also not exported as well. So instead of linking the library and using it, we really have to compile the C files and link them into our test. And to get these C files, we need the source at a static location, because we can't make any assumptions here. And the only way I can think of, the only clean way, would be to have this as a submodule. We can work with that. So I'm gonna keep this open if I want to do that. So this is marked question. So we're going to let that be a question for now. Okay, this is also very unpretty. This was this nice? Yes. This is nice issue. I think we're going to work on that. So let me explain. The protocol has nonces, and when you send a request, you create a message like pkcsrec. So everything is happening here, and you add a nonce. And this init function is actually for all client functions that create messages. So every request the client can send. And all the time we add a nonce. This is something the protocol says you should do, but it's not required. Like if you know how to read RFC, you see this capital should, and it says, yeah, if you are undecided, do it. If you have any means of doing it, do it. But the other side must not expect that you do it. It just has to handle if you do it, and it has to work with if you don't. I don't know why they allow it to be omitted, because this, I don't know, if it's a security feature, use it. If it's not, drop it. But I'm not going to judge that, or, well, I just did. I'm not, don't have any options here. I either have to implement it according to the specification or force my own ideas on it. And because we want to be compliant with the RFC, we follow the should guidance, but we cannot assume, and I'm getting to that now, something about the response, because now we go ahead and send such a nonce. But what is the server going to do? Let's look at the standard, because looking at standards is so much fun. There is the recipient and the sender nonce, right? So, right, the sender nonce must be included. Well, we do everything, so the server knows there will be a sender nonce. Now, something happens here. This recipient. So this is a server answering our request. So when we get a response from the server, this is where we expect the recipient nonce to be. And it says that the recipient should copy the sender nonce into the recipient nonce of the reply as proof of liveliness. And the requester should verify that the recipient nonce of the reply matches the sender nonce it sent in the request. So, issue 1. I don't know if the server will do that. I'll have to check if the field itself is mandatory. Okay, we'll do that later. But what I can see now, if I send a nonce, then I cannot expect the responder to copy this over. But the question is, this is copying the sender nonce over to the recipient nonce field, but the responder, so the server, also has to set the sender nonce field. I'll have to look up where it says that, but I'm pretty sure it's that way. And if it is, an interesting question arises, right? Here, the signer info, and this is valid for every PKI message, so everything we are building must contain a set of authenticated attributes. And all messages must contain, and this is all messages must contain a sender nonce. So if the server sends a response, it must contain a sender nonce, in addition to a recipient nonce. I have no idea why they did it this way, but now comes the question. What's in the sender nonce if it gets back and the server decides not to copy the value of the sender nonce into recipient nonce? And I'm going to say it must be the exact same value that he received in the sender nonce. I'm going to base my implementation on this assumption, because it doesn't say here that it should take the value from the sender nonce and set the sender nonce field again. I don't know what they were thinking designing this, like, oh, I receive a message and I just add fields and give it back because I have to sign stuff again. And so we in our library are actually building a new message when we are responding. But maybe the idea is that you can take a message and add fields. We don't do that here, but if we work under this assumption, and this seems the only reasonable assumption, because otherwise why include the sender nonce in the response as the sender nonce field and copy it into the recipient nonce. So let's assume the sender nonce in the response must be the same as the one we send. Now, the recipient nonce does not have to be the same, but we can check that the sender nonce is. Right. So that is point 1. Sender nonce in the reply the same as the sender nonce in the request. Now, this sentence here, the requester should verify that the recipient nonce of the reply matches the sender nonce it sent in the request. It should verify this. There's nothing said about the sender nonce that comes back as a field, only the recipient nonce. And in the old implementation of SSCEP, it actually checks if the recipient nonce is just the same as the sender nonce inside the reply. It does not look, if I'm correct, it does not look at the original value we sent. And this completely negates the effect of the nonce if the adversary can just copy the fields over. So, and we need to think about this. How do we verify this? Because looking at our current API, and the current API, this unwrap function, or actually this unwrap response function, and there is no way anywhere here that we can or do put the nonce. Right? So we're talking about the reply here, or a response. So this is actually the part where we're going to add that. And it should always be present. So these are just checks for the success case, and then it handles the type of the request. But this is something that happens on all responses, and we can do that after unwrapping, because beforehand we don't have access to the values that are set here. To take a look at this, we can see here that this is the complex data structure that we store the response in. And well, we store anything we unwrap it and store these parameters here, like what is the status of the request or response, or right, the PKI status I think comes only in a response. What is the fail info? What should, if it's failed, what why did it fail? What is the transaction ID? And here we have the fields for a sender and recipient nonce. And if they are set, they will have a certain value. Otherwise, they will be just null. Yeah, so let's see what we can do with that. We want to implement two checks here. And one of the checks is mandatory. So we first do a mandatory check that sender nonce in reply is same as sender nonce we originally requested. And then comes the question, what should we do with the recipient nonce? Well, we can optionally check that sender nonce in reply is same as right. The recipient nonce in reply is same as sender nonce in original request. Now, I like to think that someone is paranoid and thinks, well, there is no reason not to copy it over, and I'm talking to a server that, beyond being standard compliant, always follows this guidance. And because I know that, I want to make this mandatory. So whatever happens, I want this to fail if the recipient nonce does not match my original sender nonce. But I cannot force this on every user. I, as a developer, cannot force this. But as a user, someone might want that. And this is why we have these cool flags. And I'm going to introduce a new flag that allows us to toggle this behavior. Introduce new flag to strict mode checking requiring sender and recipient nonce equality. So this is our two things we want to implement now, and the second one actually gets a flag, so there's a third kind of behavior. Now, before we just do this, we need to test this. We write tests and do like this cool stuff called test-driven development. This is for all response types. And so we have to see where we call this function and test with it. And if I'm not mistaken, this happens in all of these test files. So test. Do we have this test? No, we don't have one for pkcsrec, but we have one here. So test unwrap makes an unwrap message, and that's not what's happening. Okay, so yes, I was wrong. It happens in this function. This is where the unwrap response part is called. It's called, is it called here? No. No. This is a little more complicated. Okay, let's take a look. So I have this unwrapping function that has a setup function that is called here, that does all kinds of stuff. and reads, reads these in and calls the unwrap response. You probably already saw that. Yes, it calls the unwrap response. Yes, so we will add something here that tests these three cases. So test unwrap wrong sender nonce. So this tests case 1. Jar test unwrap unmatching nonces warning. So this tests the case where we are not in the strict mode and we decide to drop a warning. So the operation will continue, but a warning will be issued, and we can check that. And then we do the same, but in strict mode we want to fail, right? So now we need to create cases for this, and we need to update our API. First of all, we should probably get the original sender nonce to make sure when we soon update our API and update our tests that use this API, that we use the correct sender nonce. So I'm going to add these 3 tests first. And once we're done with that, and I'm going to add them to the... Am I going to add them to the engine as well? Yes, I will. So this is going to happen here as well. There we go. So now we have these tests and they will already run. Test message. And it's, oh yeah, right. I need to export all my cool variables. There's actually an issue to what I'm exporting here. Export module path, dynamic path, path itself, export path. Path is happening as well. That might already suffice. Let's do this again. No. But I have both a module path and I called it dynamic. Is it possible I called this the wrong name? Oh, I definitely need a script for that. And it's called engine path, not dynamic path. Export engine path. Make and run the tests. And it fails with a whole lot of errors because the botan, because I still need to export the LD library path. And I can run the test again. Now I get successful checks. So okay, and now we fix that to only call the case we are working on just to speed things up. Perfectly. Now we are set up because now I'm going to make these tests all fail until we have something better. Nice. Let's start with taking a look at the correct nonce. The correct nonce will be right pkcs7 stdr, and this would be We are going to do this on the pending one because it has the least data. So it's the easiest to take a look at. Could use any of those. 1JS, right, and there we go. So this should be our nonces here. Nope. Still nope. Digest. Send a nonce. This is it. So this is the nonce as a string. And we want to do that as a character array, right? And this will require me doing Python because I don't want to write that by hand. Okay, so how do we do that best? By this should work if we do it so I'm just trying something out here for C in decode hex. Let's see if I did some major fuck up or that worked well. This looks like a C array, doesn't it? So it should be possible to paste this in right here. Char sender nonce equals this. Going to put that above here. Going to make it a static, and now we're going to format this to look a little bit nicer. I probably shouldn't be doing this in an array, should I? Could be much nicer if I did this just like this. And then make it a string. Okay, I think this is nicer. Pending sender nonce. Yes. So, what we want to have as the API now. Oh, damn. Okay. What we want to have as the API is that we can pass our nonce in, because this is the only way we are going to get it in, except I'm thinking about storing it on our handle and then just saying that you can store it in between. If you are making another call, then you need to store it on the outside and pass it in again. But it would be a nice idea to not change the API at all, and when creating a message with a sender nonce, setting it on the handle as well. I think that's a cool idea. So let's say we add exactly this, exactly here. And we assume that one handle is used for one communication request. I'm not sure how well this is currently defined, but we can just define it now. Okay, I'm going to write a test for that as well, because I need to be able to set that. No, I don't, because this is not, there needs to be a public API to retrieve and set it, so I need to write a test for that. Going to do that here. And this should be fairly quick. Test sender nonce accessor. So we're just going to, is there a setup function here? There is, okay. So we're just going to use our nonce we are using here. We're going to abuse that here. And now let's say we call this scep or scep. Let's call it scep. Scep we could call it get sender nonce, or we could call it scep sender nonce get. Or if we were to store more values, we could scep get param, and then we pass in the handle, the type, and get a value, or pass set param, pass in a handle, a type, and a value. Actually look like this. I like that. Okay, so we have a handle. The type will be defined as an enumerate. We call scep param sender nonce. Use that here, we use that here. The value will be char pointer sender nonce ref. And then we will do the check that this works. It's to be okay, because this is how we check if the call succeeded. And we will do this before setting it. ck assert int equals to be okay. And we set the sender nonce here. We pass in the sender nonce ref pointer here. And now we need to compare these two. And I need to check if check has something to check for that. Haha. So it can only check strings. And it cannot check messages of arbitrary content. So we will do a mem compare. Right, mem compare. Yes, that's right. So what does it return? It should return 0 if both are exactly the same. So we want to check if sender nonce and sender nonce ref of nonce lang are the same. And we want to add that method. that should be it. Yeah, this is actually what we want. So now we need to write these methods. So the setPara method and the getPara method with the following signature. They all return our error code. They take a handle. They take scep param. This is, I can call it like that, right? This should work. Yeah, that should work. Call it a param type. And here we pass in the value. I'm going to do this as a void pointer now, because I don't know what types we might someday set as values here. And this way we can set any values, right? So these must be pointers, and this should work fine for now. Don't see any issues with that. Now we need a function to set these parameters. So this is a little inconsequential. It is anyway, so we're going to give names here as well. Because otherwise developers might hate us. I hate developers that don't provide documentation and then just add a header file that does not really talk about what's going on. So we are going to switch over the type. And now is, I think, a good point to create the type. So our enumerations are all defined here. We add a new one. I read in the kernel documentation that it's a bad thing to type def stuff like this, but I like it. I like it a lot better than to just have to write enum or struct or something all the time. So we're going to do this with a type def again. And we don't care about the values, so we don't need to do anything else. And I like that we can set a comma here. So there's nothing more we support at the moment. And we set a default case, and I'm going to take a look at something soon. Right now I am just going to take this value and set the center nonce pointer to this. This should be the same, but oh hell, I have no idea if this makes any damn difference. And I'm actually thinking I'll copy over the value, because then I already have the space for it. So I'm going to do a mem copy of destination, and I'm going to write, I'm doing something very wrong here. The get thing should get this, and it should look this way. Great thing I noticed, right? So going to cast this as a char pointer, and I'm going to say sender, now it's called nonce length. just said if not, but what is returned? Function pointer. Can this fail? I don't know. Well, if it fails with a null, right? And we just return SB error. Otherwise, we can return OK. So I assume this cannot fail, and that's why I'm not doing anything special here. Now, for the default case, I'm going to take a look at our cool utility module, because there's actually something that will help the compiler catch unchecked values. But from what I am looking here, I don't want that, because I already decided that I want to return this value always. So instead, I'm doing something else. I think that if okay, this might actually work as well, because now the compiler might complain if I add a parameter that doesn't exist. So no default case, and the compiler will check. It will add a warning, and we die on warnings during compilation. This is something well, actually this is only done for the tests, but this should be fine anyway. So we have our parameter setting. Now retrieving a parameter. Trying to retrieve a parameter that does not exist should yield an error. And it would be cool if we already had an error for that. Invalid content. Does it say in the error message? No, that assumes data structure content. So no, we don't want the internal error. Let's say this is a parameter error. So we create a new error here, and we create it at the correct location. Libscep e param. Now let's write a nice error message. This should be generically for all parameter errors. And so we just say that the parameter. Can we say generic parameter error? Is this a nice way? I'm not so sure. Well, let's check first. What's happening here is that we know we should have a value here, but we might not, and then it would be null. And so this is a question, right? How do I check if this has been set? Because this is an error and it often behaves like a pointer, but can I assume it is a pointer here? No, right? The question is this internally represented as a pointer? And I'd say I don't know. So here comes an interesting question. How do I check if this parameter has been set? Well, I assume it is a pointer here, right? So this would already break. So let's say if not handle sender nonce, we return a scep e param. Can also, because this is a because this is a generic error message, we can say parameter sender nonce has not been set. Otherwise, we set it. And then return the OK. This looks nice like this, doesn't it? And oh, we should break here. This seems good enough. And this seems also like the perfect point to... Okay, we should also have a test for not having set that. And we need cleanup. So we have this, sender nonce. Okay. Send test sender nonce unset. So let's say we do not set it, we try to get it, and it should yield a param error. And then we don't need to pass in anything else here, because this is not set anyway and it will not be used. Now on to the last question. We need to free memory. If we are doing a cleanup, let's create a dedicated function for that. And we call as gap. Oh, I'm going to rename these functions. This is much easier and nicer. Scep param type. So we are going to rename these functions this way around. And we're going to do that here as well, of course. Doing this here, and we're doing this here. We actually do not need to do this for this function, because we're going to define it as a static function. I think we might not need an error anyway, because there's nothing else happening than switching over the type, handling the single case, gap param sender nonce, and saying if handle sender nonce free handle sender nonce break. Right? We're going to not so sure this such a good idea to have a dedicated free function, because we could also just call all these frees here, but we have that for now. Does not need to be exported, because it will be called internally. That should be it. Right? Let's try and test this. This looks great. No, who sets gap e error? What did I do? course not. And what's going on here? I just lost complete control of my API. So I of course need to give it the handle. And the handle is undeclared. Probably not. Oh, it is. It is here. Seems to be... No, we do have this. Oh. Oh, okay. So this is not a setup function. There does not exist a setup function. Then we do this. Do it here and we do it here. And now we need to rephrase that. Now this should drop out. And we have the... I must be kidding myself. First we get a parameter. First we set a parameter. And then we can get it. And now we need to cast this as a void pointer. And we need to cast this. Should probably be casting this as a void pointer as well. So this looks a lot nicer. And this is not possible. So I'm also learning my stuff here. Invalid storage class does not seem like a message I understand. I probably forgot semicolon at some point. Or maybe not. I know what I forgot. I forgot to say and test here. Because I always forget that. Okay, cross your fingers. Right. Huh. That's interesting. Let's see why I fucked up. So print handle, no, p-type handle, p-type handle, no, I know the type. I want to see what is actually going on here. The problem is probably that this is an array, so it is inlined. And the question is, yes, I want to fix that. I want to make this a lot easier for myself. I have no idea how to work with arrays. I do know how to work with pointers. I make my life a lot easier. I just need to dynamically allocate memory. That's something we all know how to do. And I actually don't need to free it then. Oh well, I didn't need to free it before. I now need to free it because I'm allocating it. So there was no need to free it. And if you're anything capable of anything, you probably noticed that, and I'm an idiot for not noticing it. I declared an array, so I don't need to free it. Question is, does it work? if I undo this change and drop the whole parameter freeing stuff shit I just created unnecessarily. It passes the checks. I think that makes me happy enough. Just for the sake of it, let's try and break on something to give me just a look inside. What the hell is going on? I'm doing something really weird here, it seems. GDB test. Something is going completely wrong right now. There it is. Not see. Oh, I did not see this error message. Okay. Now we should be able to run. That was not my idea of a running test. Because I am an idiot. And we have segmentation for it. Exactly what I feared would happen. So, what are we doing here? Having a nonce of all zeros is a valid value, so I'm going to tell you what my problem is. Because we do have a valid nonce, it's just all zeros, but it's valid. So I cannot check if it's 0 because I don't have a pointer. I can create a parameter that says which flags, which params have been set. So I could say, do I have to make this an integer or a scep params set? And I can then say that if this was set, then I say handle params set this type. I can do this here, so I have this as a general case. And the question is, if this is already set, is this a problem? I think it's not a problem to override the nonce. And here I say, if not, handle set and type and scep param sender nonce. And I can do this in a general case as well. Just the nice error message is getting lost, but I don't care about that. Parameter %d. Can I do that? No, I'm not going to do that. Oh, maybe I can do that in a macro kind of way. So maybe I can turn this into a string. Does this work, scep param sender nonce, or do I need to do a macro for that? Probably broke a lot of stuff here. Stray, right. That's what I expected to define. Fine. From error type to be this. No, to be this. And now param error type. Yes, yes, yes. Does this work? It does seem to work. Scep. And it also seems like I need some error messages to debug this. So yeah, this is not going very fluent, but we might be learning something, and that's the wrong place. So what I'm doing now is introducing error logging, and I should call it debug, but that doesn't make any difference here. No, what did I break now? Right. It says parameter type has not been set. That's not what I wanted. And now I see why this is not what works. Because the enumeration type gets lost during runtime, during compilation. So I will go a much easier way and be very lazy. And just say this. Now I don't have a string error for this, and frankly I don't care. I can do this in a prettier way later. Just now now this is, oh right, this would only work if I do it in exactly this way to make this flags. And then it works. Okay, so this was very basic stuff. It should have been basic stuff, but it took a long time to create that. Now we have our nonce, and we can already create functionality so that our current tests don't fail, but we are not going to do that right now because we will first write the test that should fail. Be failing right now. Or should I first adjust our code in such a way? So this param should now be set, and it should be checked, but I want to write the tests first so that I get this check failure. So let's first manipulate the sender nonce. And the very easiest way to do that would be to take a wrong sender nonce. So let's say sender nonce equals 0, 0, 0. This is easier, right? This could be oh, come on. Nonce length. I'm going to be lazy here. Mem set sender nonce zeros nonce length should be okay. Now, let us say we already have the nonce at these 0 values, and we now need to set it on the handle. Scep param set on the handle set scep param sender nonce to the value sender nonce. And now we are going to do the unwrapping here and expect it to fail. Scep e, and we're going to say right now this will be called invalid content. We could call it a protocol error. Let's see. We have this here. Oh, we need to write an error message here first. Very, very generic. Very much no information, but this will be provided by the logged error message. So it either says the content to be invalid, no, a parameter was invalid, invalid protocol operation. Yes, this is what we want from the error message. This looks exactly what we want as an error. So invalid parameter should be what we are getting back. And now we don't want to, in both other cases, we do not want to alter the nonce that is inside here, but actually we want to alter the nonce that is on the response. So this recipient nonce. Okay, let us see if we have done something like that before. We have not. We need to work with the nonce, and the nonce is getting set right here. No, here it is not set, it's just backed up, so it can be used, for example, here, or more interestingly in our PKI message function here. That's it, an ASN octet string. That's the function signature we want. And now we want to, so this is, we need access to the signed attribute. Let's take things one at a time. No, this is actually okay here. It's just scep e okay. Now we already have no. This is the only case that should be done. This is not something we are doing at all right now. And let us see. Data undeclared. Because I need to say this first. No, it's a scep data. I really am not at my brightest today. Test message. No, I did not. It's a test message. That's what I want. What did fail? Fail, fail, and fail. So 3 tests fail. Assertion 0 failed. Right, so this is the first test that failed. And it failed because we expected it to fail. Now we are going to write a test for that. Unwrapping the response, we are going to say first retrieve the nonce. Oh, right, that's actually made easy for us because we already have this here. If not, mem compare between our local out the sender nonce and first of course we need to retrieve the parameter, right? So we want to take the handle and take the scep param sender nonce and we want it passed into this. And now we need to make sure. Here we might need an informative error message because this can happen if a user forgets that. So this is an error case and we want to tell the user that a sender nonce needs to be set. And I think that should cover it. And actually, you know what? I'm going to say go to finally because that's what we do here. And I'm going to take this error just over from here and be very nasty. Okay, so this could look a little bit nicer if we were doing it like this. Then we make sure that the... Oh, did I make an error in my original test? I'll see soon. First, now I'm going to do this here. I'm going to... Oh, I have to do this here. Going to compare them on the nonce length. And if they are not equal to 0, going to say scep block handle error. Send nonce parameter returned. Send a nonce parameter inside PKI message does not match original nonce. Then I'm going to set the error to invalid parameter. That's what we chose. And I'm going to say go to finally. And that should cover it here. Now I want to see... Oh, right, I did it this way. So this is okay. So now I have this implemented and this test should pass if I did not do something wrong. That is actually what we want to see because I did something wrong. I did not create a function that sets this where the sender nonce is set. So right, let me rephrase that. If we create a message ourselves, we of course need to set this parameter on the handle. Otherwise, we get the error message and a failure. And that's why I am going to set this right here. Scep param set on the handle the scep param sender nonce to void pointer sender nonce. So that's what's happening here. And we need that at another place because this happens twice. It happens in the PKI message function as well. That's what's happening here. And we do that at this point. And we do it in this way. Then we should be good to go. That is exactly not what we want. We need to see where this happens. It happens on the unwrapping of a message we did not create ourselves. And that is very stupid. So all these pending stuff, messages and so on, they all need this parameter to be set correctly and explicitly. So let me go to this exact location and get started. Not set it to this, but to sender nonce. Oh, there was it. Pending sender nonce. Is that what it was called? Sender nonce? Right. And that I can do for everything that has this pending variable. But that will not be all. Let's first see if this already reduces the number of failing tests from 5. Still 5. Not very nice. So wait. It was 5 before, it's 5 now. Why is that? It should not have been 5 before. If I take a look at this invalid sig cram stuff, yeah, crams, right. And I see that invalid sig is not called in any ways. This is not a test that, oh, right, it's used here. So why is this not an issue if I comment this out? Why is it still 5? It's checking 9. 2, 3, 4, 5, 6, 7, 8, 9. Oh, I know why. I know why. Because this fails before we get to the point. That's okay. Because we really don't care about that then. But this is the one that should be. And we actually might have an interesting case here. Because it seems to be the wrong nonce. Okay, let's debug that. So we don't fork here. This means GDB can run on it. We will break on test message search rep online 399. We will run. Now we will break here at this, no, at this point. So 677. Break 677. C. Right. Print local out sender nonce. Now print sender nonce. Completely different. 1C sender nonce. X1C local out sender nonce. So is 3 for what we initially provided here? No, we should be providing C5, but we are not. Okay, maybe, really just maybe doing something really wrong here. So that's what should be in this. And it's not, and I don't know why it's not. Let's see if we can get this as a hexadecimal value sender nonce 34. So why is that happening? It's working here, right? So if I do this here, this looks, no, it does look the same as, no, what's going on here? Oh, right, it does look the same. It does look exactly like I expected it to be. And then I set this value, and what I get back is then a broken value? Because why? X16C handle sender nonce. This is also correct. So I'm way off base here. So this is correct. But the parameter I get back here is not. This looks totally broken. And I have no idea why. Why is this broken? So we need to break on 671. X16C sender nonce. This is what it's in there right now. What happens if I get to this point? So it did change, but it changed to a very invalid value. No, please do not tell me that I am just copying over the pointer. That's the problem. Look at that. I'm an idiot. So what I'm assigning here, I should be copying the memory. Well, what do you say? Why did these tests not reveal that? Because I was working with an array here, with a pointer here. So let's fix that. And this does not work anymore. Great! Now we're getting somewhere. Let us say we just don't set it, we say we do it like this, and we probably need to dereference this. Treat this as the char pointer and then cleanly dereference this. Let's make this again. It's sec false. That is not nice. Why does it do that? What's going on here? I'm an idiot. A freaking idiot. I want to get the parameter. So let's start over. I need to dereference this, what I call char pointer. I need to set it to the value of handle sender nonce. Great. What's going on now? Right, because this seems like the correct way to fail. Let's break at scap C 131 and run. And say that value is a void pointer, right? And what is in value? x16c value. There's just nothing. This seems to be reasonable. And now we say this on the sender nonce. Then we have a value. Now we are going to mem copy this over. And see that this is at the correct place. But we will not understand where this breaks. So there we might have a problem. I really don't get it. If I pass in a reference to a char array, okay, I need to think about this. So what I get here, what I actually had here, is the value, this one. It says this address. And now I take sender nonce ref, and it tells me this is the same. That cannot be. How is it possible that these two point to the same address when I make a when I make reference out of it? This would mean that I don't need to dereference it and just treat it as a char pointer. And now I'm thoroughly confused by this. Okay, I have no idea why this works. This seems to be a very working way, and I do not get why. Then again, if I'm doing it like this, I don't care. Really, at this point, I do not care. I will check this, but it seems to work for now. That leaves me a happy guy. So let's get back to testing the real stuff. There we go. We have 4 failures on success and failure case, on warning and strict. That seems to be pretty close to what we expect, because I did not create these attributes for the other cases. I'm not sure that I will do. Or maybe I will do. I'm thinking about what's the quicker way. I think the quicker way is to copy the extraction process here and just statically set it. And that's what I'm going to do, I think. So to get nonce, we look at the unwrapping process. That gets the nonce here. And we are going to use that here. So that's what's already happening. And now I need the SI object, which is the signer info, which is exactly this. So you notice that this is a unit test, so I'm taking out all those sanity checks just because I assume I know this is going to happen. If we have a sec fault, we have a whole different issue. P stack of pkcs7 signer info should be correct, and pkcs7 signer info should be correct. I don't know what a signed attribute type is. ASN1 type seems legit. So we have this. This is a pointer as well. This is okay. I think the last part to worry about is this sender nonce stuff, right? No, what's going on? I might have skipped over something important. We get the octet string. Oh no, this is where it's going. So instead of going here, I need to have a char sender nonce length, and we'll pass that in here. Right. And now I'm going to check that. I think by just running the test, make and see. CS7 gets signer info. Here I need to use this object. It's really getting late. Did the success case still fail? Yes, it did. Why did it? And it failed. Probably at the point where it says it. Wait, I'm on the pending one here. This is so stupid of me. Should be doing this here. And I should be doing this. Wait, I should be doing this here on the success case. Now only the failure case failed. Ha ha ha. So we do this here as well with the failure case. And we only have 2 failing tests, and these are our new ones. And additionally, I don't think we need this one anymore. Let's see what happens. Yup. It does still work. And now we should check for warnings. I need to think of a way to check for warnings. So I'm going to put that off and enter strict mode. And I need to take a look. Right, it was set by setting a flag. So to set our strict flag, we want to use our configuration tool that has a function called, where is it? Oh, I marked these as internal, that's wrong. These are not internal functions. These are external functions. Right, scep conf set. This is, oh, I should not move this now. It would be an unclean commit. Okay, so we need to figure out the correct type to set a flag. I know, I probably have documentation for this, and if not, I should now write some. But I don't want to, and instead I'm going to find out what our configuration. This is it. Set a flag. So scep conf set a flag, and I want to set the flag. I need to create first. Scep strict sender nonce. Yes, 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 and yes. Yes, this is good. If we are creating such an enumeration that is used as flags and flags should be checked, then we want to imagine flags as a string of binary digits 0, 1 and check if 1 or 0 is at a certain location in this bit string. And so we need to know the representation, or we need to write it as binary. And because I'm lazy, I don't write it as binary, I write it as hex digits, because there it's easy but still short. And the 1 in the first line here has the least significant bit, the first bit if you want, so set as 1 and everything else is 0. And if I write 2, then the second bit is 1 and the last bit is 0. And that's important because if I were writing a 3 now and I have 1, 1, then it would be both of these flags set. So that's why I need to do the 4 here, because then the third bit is going to be set to 1 and the other two are not. And if I want to enable multiple flags and then check for the presence of one of them, then I can do this, because if I perform an OR operation on these, so I can say this flag or this flag, then the resulting value will be 6, or in binary 1, 1, 0. And then I can check for the first or the second flag, and the last flag, the third flag, will not be set. Right. I have set this. I want to set this flag. Where want I? I want to set this flag here. I created it. I set it now. And now I want to make sure that we are able to change the nonce. So I want to set this on an ASN1 object, and first I need the ASN1 object. So let's look at how this is created. And the PKI message function will give us exactly what we need. Creates us this octet string. Actually, we can take all of this, but we will name it recipient nonce. Next thing, we do this octet string set, what we already have. We call this, and I think I'm going to do this here with a sender nonce length and mem set that to 0. That's basically it. Then we can say sender nonce here. And we can head to the next step. Now there we might need more parameters to get them. So we have this, we have this, we have this if we rename it. And we need to rename this. And we should rename this as recipient nonce, right? Much nicer. Now, this signer info we need. And to get a signer info, we need a private key. And we need the private key used on this. And this is getting a little more complicated than I'd like, because we need to do this on an existing PKCS7 object. And to do this, I can actually do this here, but it will invalidate the signature, because I need to sign that again. Right. Never mind that. We first start with this. So, get our signer info here. That will contain that we will use. Okay, we're currently working on this one. Okay, right now we need to duplicate this. Because otherwise we will get into problems when use this later on, and we will do this here too. We don't need to do this here. But here we are modifying the content that we globally load once, and we will break other checks if we modify that in place. So now we have an invalid signature, but at least it should work up to this point. Let's see. No. Because of what? Where are we? All right. And to be totally clean. That's CS7 so wrapped up right. This one, we can make that. And we have the ASN recipient nonce, ASN 1 octet string. And the P7 data. Now we're getting somewhere because this is now here like this. And we have a failed verification. Okay, I'm going to disable all the other tests to get rid of the noise. Right, the verification failed, and that is exactly what we expected, because we need to sign that again. And I know I did this in one test at least. I did this. This won't get me any further. Sign. Let's do this correctly. Sign. No. Here we just get the signer info. So let's see if. No, probably not. Not what I want. Crap. Now I have to wait. Let's see. Let's continue. So the common one I checked. This one doesn't have it. This one does have a request signing. Nothing more. Okay, so let us see how we can create a valid signature of that. I thought I had this somewhere, so let's see. The original version will suck because it has this add signature stuff. And instead of saying add signature that yields a new signer info object, I want to sign something with an existing signer object or provide a key. That's what I want. I don't know how this works. I don't know how I do that. But I know someone that has cool header files. Actually, it's possible a lot. It's possible to get around with OpenSSL by reading files a lot, and the documentation they provide is to some degree you can work with it. It's okay. So never mind that. So this is what I saw, but that's not what I'm curious about. Instead, signer info set. That looks good. Except, no, this could work. Let's try that. So let's try to say, I'm really going out on a limb here. I'm just trying stuff because that's how OpenSSL works. Unfortunately. Not the correct place, the very correct place. I need to get the correct key and certificate and digest. And The digest I can get from here. And then we have two parameters missing. First the certificate, then the key. And we need to use the same key and certificate that were used to originally create this. And now we might get a problem. Because I'm not sure how these values were created. But I can weasel around that because I have a cool make message function that will create me a cert rep message and will allow me to cool it. I see the sender nonce here. And what I want to do is, okay, I want to use that first. So let's use one of the nicer tricks of Sublime and take a look at the same file twice. So instead of creating this message, we are going to name it just the cert rep and call make message on this with the PKI status. So let's see when and how make message is called, because this is the easiest way to do stuff. That's the shortest message possible. And there we are. Now I know exactly which key and cert I used. So let's hope that if I do this and then pkcs7 signer info sign, that this will work. And because I assume it doesn't, I'm printing errors here. We did not get any error message, so the verification process should have worked. It seems. But I have no idea if it actually worked. Where we are heading. Great. Let's say, take a look at this. And we break at 557. No, break 557. Not in the current file because I need to spell it out exactly for him. 557. Test. Yes, because message does have 3 R's in it, S's in it. There we go. Let's step into it. Didn't take a look at what is actually returned because it doesn't tell me. So let us see. We are now in the unwrap response function.